Most of your science teachers have probably told you sound travels faster in denser objects. However, pretty soon you will figure out that this is actually completely incorrect. Well, you might be like, doesn't sound travel faster in water because it's denser? Well, water not only has a property called density, but it also has a property called bulk modulus. And usually in denser objects like water, the bulk modulus is also much higher, and thus being able to overtake the density and make sound travel faster in water. However, let's go back to what we initially wanted to prove. How do we prove that sound travels slower in denser objects? One important key factor that we can take here is temperature. One thing we know about temperature is that high temperature means low density, and low temperature means high density. So we can look at the speed of sound at different temperatures to be able to prove this. So first, let's look at the speed of sound at 20 Celsius, which is room temperature. The speed of sound in room temperature is 343 meters per second. Now let's look at the speed of sound at freezing. The speed of sound at freezing is 331.3 meters per second. And of course, this is slower, even though the density is much higher at freezing than at room temperature. This proves that sound must travel slower in denser objects, and we have successfully proved that sound travels slower in denser objects.